Alright, so in this video we're going to learn how to solve quadratic equations by factoring. And these particular quadratic equations will be in the form of x squared plus bx plus c. And if you're not familiar with how to factor expressions in this form, please see my video, Factoring Expressions in the Form of x squared plus bx plus c. Alright, so we're going to solve these quadratic equations by factoring. So let's get started. The first thing we want to do, we want to find two factors of c, which is our last term, that have a sum of b, which is our middle term here. Because remember, should have erased it. This is c and this is b. Alright, so two factors of 10, that when we multiply we get 10, but when we add we get 7. So that would be 5 and 2, right? Because when I add 5 and 2, I get 7, but when I multiply it, I get 10. So my factors are 5 and 2. So I'm going to write my binomials, meaning it has two terms. We want to use our variable that we're given. So that would be x and x. Since the 5 and the 2 is positive, that would be plus 5 and plus 2. And I could switch it. I could do x plus 2 and x plus 5. It doesn't matter, all right? As long as I have the same binomials. So now I factor this expression, and I want to solve it. And what I do, I just set each binomial, so x plus 5, I set it equal to 0. X plus 5 and x plus 2, set them equal to 0. And then I just solve it. So one-step equation, subtract 5, x is negative 5. Another one-step equation, subtract 2, x is negative 2. And as you can see, we really just changed the sign, all right? And so this is my answer. These are my solutions to this quadratic equation. Most of the time, you're going to have two solutions when you're solving quadratic equations. You may have one, you may have no solutions, but a lot of times you will have two solutions for your equations. So we could check it. We could plug in our answers to see if it equals 0. All right, so that's how we check it. Because remember that solutions to a quadratic equation are, another term for solution is zeros. And what are the zeros? The zeros are where that graph crosses the x-axis. All right, and so that is why we have x equals. All right, so when we plug it in, we should get 0. So let's check it. Let's see. So I'm going to plug in negative 5. Negative 5 squared plus 7 times negative 5 plus 10. It should equal 0. Negative 5 squared is 25. 7 times negative 5 is negative 35 plus 10. Combining these, negative 10 plus 10, and it does in fact give me 0. So that checks out. Let's try negative 2. And of course you don't have to do this for every problem. I'm just doing this to show you how you could check your answers and what the answers mean. These are the zeros. So I'm plugging in negative 2 squared plus 7 times negative 2 plus 10. Negative 2 squared is positive 4. That's minus 14 because that's a negative 2. And 4 minus 14 is negative 10 plus 10. And again, that does in fact give me 0. So I've checked my answers. It should give you 0 if your equation equals 0 here. So my solutions are negative x equals negative 5 and x equals negative 2. All right. So now let's try this equation here. All right. And I want my equation to equal 0. All right. So this 8 is on the right hand side. I want to move it to the other side. So what do? I want to use inverse operations. So since this is a positive 8, I simply want to subtract 8 from both sides. And I'm left with x squared plus 2x minus 8 equals 0. All right. I can't combine it with any other term over here because it is not a like term. It is a constant. And so I leave it separate. All right. But now it's in that form, x squared plus bx plus c. So I can factor it the same way. Factors of -8 that have a sum of 2. So 4 and 2. All right. I know one of them has to be negative. So that should be a -2. Okay, because 4 times -2 does in fact give me -8. But when I add it, 4 plus -2, which is the same as 4 minus 2, that gives me a +2. So that is what I want. So my 4 has to be positive, my 2 has to be negative. If they were flipped, if the 4 was negative and the 2 was positive, when I add it, I will get a -2. So I have to use my correct sign. So that would be x plus 4 and x minus 2. All right. And then same steps. Set it equal to 0. Subtract 4. X equals -4. Add 2. X equals 2. And I crossed out my answer trying to circle it. All right. So that is my answer. All right. So I can either, if I want to check it, I could either plug it in to this new equation, or I could plug it into the original. So let's check it mentally. If I plug in -4, -4 squared is a +16, and plus 2 times -4. 2 times -4 is -8. So that would be 16 minus 8. That does in fact give me 8. So I would always at least check it mentally. All right. And let's try this last one over here. So we notice we have a number in front of the x squared term. All right. So when we have our quadratic expressions and we want to solve it by, or equations, and we want to solve it by factoring, we want to always look to see if we have a greatest common factor. So basically, what factor do all three of these terms have in common? And in this particular equation, they have a 2 in common. That is their greatest common factor. So I could factor out a 2. All right. Because all of these have factors of 2. And then on the inside of my parentheses, I just want to divide. And I also have a video on factoring greatest common factors, or by using greatest common factor if you need a little help with this type of factoring. But I factor out a 2. And so I divide all my terms. 2x squared divided by 2, I'm just left with x squared. -2x divided by 2, that leaves me with -x. So it's like I'm taking out a 2. And -4 divided by 2 is a -2. All right. So now I factor what's left inside of my parentheses. So 2 factors of -2 that have a sum of -1. Remember, if you don't see a number in front of your variable, it is an understood 1. In this case, it is a -1 because we have a minus sign. So my only factors of 2 are 1 and 2, but I know it has to be negative. So factors of -2 that have a sum of -1. That would be 2, or -2, and +1, right? Because when I multiply it, I get -2. But when I add it, -2 plus 1, I get -1. So I have to use -2 and +1. So my binomials are x minus 2 and x plus 1. All right. So now I want to set my binomials equal to 0. Well, what do I do with this 2 here? Well, I could kind of just throw it away, because if I set 2 equal to 0, that doesn't make any sense. That does not work. So I don't need it. All right. But I could set the rest of my binomials, or my binomials I have, equal to 0. So this is not possible, but I want to set each one equal to 0. And by now, hopefully you notice that you're just changing your sign. X equals 2. X equals -1. All right. And so we have solved these quadratic expression or quadratic equations in the form of x squared plus bx plus c by factoring. All right, so I have 3 problems here that I would like for you to try on your own. So go ahead and pause the video and try these 3 problems. All right, so I hope you got the problems correct. Check your answers. X equals -5, x equals 1, x equals -8, and x equals -6. Last problem was probably a little tricky. I wanted to throw that in there to kind of give you some more practice on these harder problems that are a little more challenging. So you had to move the 18 and the -12 over, or you could have moved the -2x squared over. But I moved it to the right, so when I move over the -12, that becomes positive 12x, and the 18 becomes negative. Remember, when you move anything across the equal sign, you have to use inverse operations. So my sign changed here. I had to factor out a -2, so you can factor out negatives because I wanted this to be an x squared, all right? So this could not be a negative. So I factored out a -2. My 2 binomials were x minus 3 and x minus 3. And so I actually ended up with 1 solution. So you can get 1 solution, all right? Hopefully you got it correct. If not, go ahead and just pause the video and analyze my work a little bit more, all right? So we reached the end of our lesson, and I want to thank you for learning with me.